All right, so this is my Module 6 project. We're going to start with the series circuit. So for the series circuit, I predict that the brightest will be the 30 ohm light bulb, followed by the 20, and then the 10 ohm. My reasoning is that increasing the resistance of the light bulb will decrease the current, essentially slowing down the flow of electrons as they pass through the light bulb. So yeah, I'm predicting that this current is going to be slowed down. And then as we can see, this 30 ohm is the brightest, and then 20, and then 10. And then from my results, you can infer that my hypothesis is correct. To test why I'm correct, I can reduce all of the light bulb's resistance to 10 ohms. And as you can see, the current will increase. So if I bring these all back down to 10 and decrease that resistance, you can see that that current goes up. So we'll just bring these back so that everything is set. Okay. And then we can also see in the series that when resistance is decreased, we see a consistent voltage drop and no change in current. So when we test the voltage, you can see that it's going to be 4.5 and then 3, so down 1.5 and then 1.5 again. So the voltage drop is consistent as we decrease the resistance consistently. I think this further illustrates Ohm's law, as it states that when resistance increases, so will voltage. And using Power's law, we can see an increased change in voltage leads to an increased wattage. So since this voltage is so high here, it's going to increase the power outage of this light bulb. And then for the parallel circuit, I predicted that the 10 ohm, or the light bulb with the least resistance, which is going to be right here, will be the brightest, followed by the 20 and then the 30 ohm. My hypothesis is that since the 10 ohm is the closest and is in the path with least resistance, the current will be higher here, causing it to glow brighter. So I think that the electrons are going to flow easier through here than going down these wires here and going through a tougher light bulb with more resistance. I think it's going to flow a lot faster here, and that will increase the wattage. So let's run that. And then as we can see, the 10 ohm is the brightest, followed by the 20, and then the 30. And this is different is because the current actually changes in a parallel. So we can see that the current is 0.9 here, 0.45, and 0.3. So the electrons are going to run a lot faster through this one right here. And then with these results, we can see my hypothesis was correct. Even though there is greater resistance in the other bulbs, the current of each light bulb is different because it's a parallel circuit. Since the flow of electrons is much higher in the first bulb, so will the wattage or the brightness of the bulb. With Power's law, we can see that any increase in current will drastically increase power. So we can see that right here. If this is the current right here, and if we increase it even a little bit, it's going to get squared. So that's definitely going to increase that. In a parallel circuit, we can also see that there's no change in voltage and that the current decreases with added resistance. So if we test out the voltage right here, it's going to be 9 there, and 9 here, and 9 here. So it's just going to be the exact opposite of the series in that voltage stays the same and current changes. And yeah, that's it.